Started. So we're gonna talk about pain. We're gonna talk about legacy code bases. So when up, first of all, I need to define what I speak about when I talk about legacy code, because for many people, legacy code is something different. For most people, in my experience, it means shitty code you have to deal with. Uh, a lot of people are also familiar with Michael Feather's definition, which is a code that is not tested, and it's a good definition. I like to use a different one because I like the nuances it brings. So this one, profitable code that you're afraid to change. The first part is the profitable part because profitable or variable maybe, but if you're dealing with this code, it's probably that it's so code of your company that you have to maintain because you cannot just throw it away. It has some value, otherwise you wouldn't be here trying to fix bugs or add features or change its behavior. You won't be maintaining it. If you're maintaining it, yes, it may be painful, but also it means that it's successful somewhat. I've worked on startup code that got thrown away, or the startup just failed, and this code is not maintained anymore. In a sense, there is a lot of legacy code out there, but it also means that this code is very valuable, it is successful, and it's probably paying for a salary. So it's a nice twist that I like to remind myself about. The next part is, of course, if it was all a unicorn and rainbows, we wouldn't be here. But this code is particularly painful to work with, and you're afraid to change it. There are objective reasons for that, but there are also personal reasons for that, like skills and stuff. Uh, the best example I have in mind is if you have been working on the code for 3 years, there are things you're familiar with, and it's not as scary as if you're onboarding a new code base and you're completely unfamiliar with the code base. So there are things you can do yourself that will make you less afraid of changing that code, and stuff you can learn, which is what we're going to talk about. This is a picture of you in your code base as I imagine it. So of course, when we're talking about this kind of legacy code base, I think about outdated documentation. If you ever have documentation, maybe not even. No test, at least on the part you want to change. Of course, there is no test. And all of this will be tricky enough, but there is another subtle one that many people tend to forget. The reality is, it's not like you have 3 months in front of you to change it. You have short deadlines. Everyone is under time pressure of you need to deliver things by Friday, by the end of the month, or maybe by yesterday. So it's always rushing in production, and you have to deal with all of this. It's a challenge because of all of these constraints at the same time. So, told you my name is Nicolas. I have a blog under legacycode.com. If you're not familiar with it, I encourage you to have a look at it. You will have access to the slides. I will share it with you, or Cedric maybe will send it to all of you
Yes, I will.
afterwards. So don't worry about the links, etc. I put them all in the slides. You will have them. Today, I'm going to present you 7 techniques. There are much more techniques, but I picked 7 that are quite different. And my hope is that you will discover some of them and try at least one of these the next time you're working on code. So let's dive in. The first technique I want to talk about is called ADR. ADR stands for Architecture Decision Record. This is something that is becoming more and more popular. GitHub wrote a blog post about that, I think, 2 years ago. So more and more people are aware of this, but a lot of people still don't know what this is. So what this is, it's a type of documentation, but it's a special documentation because this documentation is never outdated. How do you make a documentation not outdated? Well, the goal of this documentation is not to document how the system is working today, evergreen. So that's how it's not outdated. It's more a snapshot in history. It means you cannot be wrong. When you write an architecture decision record, your goal is to put in a document, simple document, you will see that in a minute, the reasons why you're doing something, you're taking a decision, and you're adding the context. Why? Because this context is typically what's missing in 6 months or 1 year, or when someone else will have to figure out something and they will be like, what the fuck, this is working like that, why? And usually that knowledge is gone, long gone. The developer is also gone, and you don't know, and you have no clue why things are like this. With ADRs in your code base, if you get into the habit of capturing these, you're much more likely to find out why, or at least much more information. And it's not super complicated to do. Basically, an ADR looks like this. First of all, you have the title of the ADR, of the date, metadata. I keep it simple, but like just context. Then you have the second part, which is the context part. And here you put everything that is relevant to explain this decision. So you're making, this is an actual ADR I had to work with. I didn't wrote it, but it was useful to me when I was debugging something because I couldn't understand why something was working like that. So it was decided to never read on the main database. And the context was, well, we have problems because our logs when we read, and we have this PR that shows a bug, and this, etc. So anything you can think of that would explain why you're doing this today. It could be problems you have, constraints, like we're stuck with this version of this library, and so we don't have the choice but to use that. Could be also the skills of and the preferences of the current team. Like maybe today the team is not familiar with functional programming, so we're not gonna go for this solution, but instead for this one. Like all of this is the context. Then you have the decision, which is the heart of the ADR. It's basically the title in a bit more words, just what are you doing exactly? In this case, it has been decided that we're going to just use the main database to read, and you can opt in with a property, but by default, it will never read from the main database. And there is even a PR link. And finally, the consequences. This is interesting because if you take a decision, usually it's to achieve something. So there are pros. But sometimes, often, I would say, there are trade-offs. There are things that you may anticipate already that will be harder to do or will be problematic. List them here. This is in time, like this was a decision taken on the 6th of May 2020. It may be revisited later. Maybe the context has changed, or the team has discovered something else, etc., or you realize something else. So you will have another ADR that supersedes the previous one, and then they will be referenced, so you can follow the evolution of the decisions in this project. It's not just. Yep. Yeah.
Sorry, we have a question in the chat. Thor is asking, do you have some kind of example of decision you would record? So you just gave it, but the decision you would not record.
Yes, it's the question you will have. You need to practice it. What I'm giving you here are examples of other people doing it on open source. So here's an example of the UK Ministry of Justice. Like you would be able to click the link and see what kind of things they record. Of course, there can be, like, you need to find the balance because you don't want to write an ADR for every single small decision. Typically, the small decisions that only are located in a part of the code, like writing an ADR for that part of the code is overkill, in my opinion. But you don't want to just make an ADR for like big architectural decision. It can be more than this. For instance, it could be decisions about how you work on the project, like on a project a few years ago, the environment, it was VS Code extension, but the environment wasn't great to write integrated tests. So we decided to not have any integrated tests, which means some parts of the code will not be automatically tested, but on the other side, we will be able to test fast other parts of the code. And then later, this was revisited, but that we captured that because it was an important decision on why we are deciding to do this. So decisions you take with your team about how we work. A library you install, for instance, of course, not a small utility, but maybe if you're choosing between multiple different libraries to achieve a problem and you pick one, record why you're picking this one instead of another one could be a good idea. Or yeah, the architecture, why you decide to organize your components like this or stuff like that. Example here, there is a CLI tool that you can use. It's called ADR tools. If you look at the ADR, there are markdown files. So it's simple file, nothing fancy. It's important to put them along the source code. Why? Because these documents are mostly for the developers. So when you're looking for something in the code, trying to understand how things are working, if these files are in your code base, they will surface. You will find them when you search for keywords. And if you put them on Confluence or something external, it will be much harder and less likely that you use them. Put them markdown file inside the code in a folder. The tool is just here to help you do the boilerplate. So you do ADR, the title, and it creates a new template that you just fill in the blanks, and that's it. I really like to do that and put the if I do write an ADR for a PR, then I will copy paste the body and put it in the PR description because it's relevant information. It's something that will be interesting for others to understand and discuss. So that's it for the ADRs. I need to refocus on the presentation here. Next technique, the brain dump. Oh, and if you do have questions again about ADR, you can still pop them in the questions, and we will answer them as we go or at the end. It's fine. The brain dump. So we're moving to something totally different. Here, it's more about how you interact with code you're not familiar with. And actually, it's based on, it's not just for code, it's how the human brain is working in general. And we're not very good at storing information, at least short-term memory. It's not something we're super good at. It's like the research is saying that we can hold like 7 items in short-term memory at a time, plus or minus 2. And there are techniques to make that more useful. For instance, we do chunking. Like if I give you my phone number, you will be more likely to remember it if I do chunks, like 3, 5 numbers, instead of spitting out every single digit one after the other, and you will forget some of them. The thing is, when you're working with legacy code, it's a bit complicated because you have so many things going on at the same time, and it's hard to remember what you were doing because there are a lot of distractions. So the idea here of the brain dump is to have sort of a second brain, right? Something that will store for interesting information that you can tap into at any time, something that will do the storage for you. So you can focus on the relationship, the thinking, the one thing you're working on right now, and move your distractions out of your brain on some other thing. And this thing exists. And I could go fancy, but I really like to go simple tech. And I personally use a piece of paper and a pen. I've tried many different things. Yes, there are tools online to do that, but to me, this is super efficient. This is good enough. And it's good because it means it's very easy for you to get started. If you are not doing that today already, I already encourage you to always have a piece of paper and a pen next to you when you are working. But now, like if I stop here, it will be like me telling you you should take notes. Next tips, and it's good, but it could be better. I like to compare this to meditation because anyone is capable of meditating, but it still takes practice to do it correctly. And here it's the same here. Like, yeah, sure, anyone can take notes, and maybe you're doing this already, but the way of taking notes in an efficient way to support your work, especially when dealing with legacy code. It worked with other things, but I really like this technique when I deal with code I'm not familiar with, because this is when I have a lot of thoughts when I'm reading the code. I'm like, oh, this is bad. This should be extracted. This should be renamed. This blah blah blah. But the approach of taking notes efficiently, it's not that complicated. It's you write down the one thing you want to do. the one thing you're focusing on, the one thing you do, one thing at a time. So you write it down. You can even circle it. That usually I do that. I circle the bullet points. I'm doing this. So that's what I'm doing. Now, when I see things and I think about things, what I do is I write them down as other bullet points. By doing that at this moment, instead of getting distracted, your brain knows that, okay, I can let go that information. It's here. I will get back to you. It's something I trust. I'm getting into the habit of doing that. So my brain knows it can just get back to what I was doing. And then once I'm done, I can scratch what I've done and I can look at everything I've noted and pick the next thing. And I keep doing that. Sounds simple, but it helps me stay focused, do one thing at a time, which is very important to avoid the tunnel effect. The tunnel effect is when you try doing something, like I changed this, but I'm saying that, so I will do that while I'm at it. And then I'm doing that. And then I'm in a state where nothing works. I'm not sure when I will be done. And I'm in this uncomfortable state of things are not working anymore, but I have so much work that I've done that I need to push it to the finish line, except I don't know if I'm finished in 5 minutes or in 2 days. Exaggerating a little bit, but I guess you get the idea. All right, the next tips I want to share with you, it's something different, but still about how we work. This one is about committing. So I call it over committing because I want to insist on the exaggeration. Some people call that micro committing because they insist on the topic, the subject that is committed. But you already know, you probably have heard of that before. What I'm giving you here is how to do it or how I did it. Um, it's very possible that you will be thinking, yes, I know I need to do more smaller commits, much frequent, more smaller commits. And usually you don't. And why you don't, at least in my case, it was because I'm doing something and then I'm doing another thing and I'm not thinking about making a commit. And it's only once I'm done with my bug fix or feature, or maybe after an hour, that now I realize, oh, maybe I should do a commit, right? And the problem with big, large commits is that they are harder to review. A lot of things are mixed together. Often I see people, they do git commit everything and they have console logs or maybe, secret stuff that should not be in the commit, but they just get flipped through because they are not, there are so many things at once that you're not aware of everything you put. So you're not aware of all of the work. It's much easier when your commit is small because you only have like 5 lines that you're committing. So you can name this, and if you have a console log, you will see it already. How you make that happen? I have a picture here, but I have here next to me always a gym timer. Why a gym timer? Because this thing can buzz at an interval. And that's cool because you can configure, like, for example, every 5 minutes for an hour, you put it in your pocket. And every 5 minutes, you will get a gentle reminder of, hey, maybe it's a good time to make a commit. Maybe it's not, but maybe it is. And it's just having that constant reminder. And you don't have to like stop the timer and launch the timer again, etc. So it's very gentle, but it's a good way to get into the habit of thinking about it. So start with every 5 minutes, then maybe every 2 minutes, and then eventually, after you practice it, it will become more natural. So this is an example. I'm not using it today for committing anymore because now I don't do commits every 2 minutes. I commit when I make something small that is meaningful. For example, I will extract a variable, I will make a commit. Once you get used to it, it's actually super quick to do that. So it doesn't disturb it doesn't interrupt me while I'm working. I do a commit very quickly, but then I have a checkpoint. And sometimes I realized when I was looking at my PRs that sometimes I have a checkpoint every 10 seconds, and then sometimes there are like 10 minutes between two checkpoints. Um, it has proven handy for me when I wanted to revert a little bit in the past at a moment where I knew it was working and try something else. I've done that a few times, and it was handy to have that. I realized also for my coworkers, it was nice because I was concerned about the number of commits, like having too many commits. Turns out for many people, they don't really care because most teams are still working with pull requests and then eventually they squash or they merge. And so at the end of the day, on the main Git history, if that's your concern, it's not really a problem. I've applied it at multiple places, not really a problem, but it's easier to review. I don't know if you're aware, but if you're doing pull requests and reviews, you can also review commit by commit. And some of my colleagues really like to do that because they could follow what I did.
Mm.
And sometimes you end up like, this is a commit that just does an extraction. It's a simple refactor. I can skip this. And then they can only focus on the meaningful parts, which are you remove the distraction, all the noise from these. So I know some co-workers of mine, they told me they liked it actually. So
We have a question, Nicolas, from Hugo. He wonders, is it a problem if during the pull request process, I guess just after the merge, all the commit gets squashed? I guess you lose the history or something. Is
yes,
it a problem?
it's not ideal. It's not ideal. Yes, when you squash all the comments, you lose history, you lose interesting information. Uh, I actually don't mind a long commit history with a lot of comments because most of them you don't get into them. Uh, it's less of a problem if you keep your PR short and small and not long-lived. So if you,
Mm.
like within a day or within a few days, if you're going over a week, you have problems. But in general, it's all about this discussion of trunk-based development versus pull requests. Still, most teams are doing pull requests. Uh, the longer the branch is, so the more commits and stuff there is in the branch, the more a problem it is to squash everything into a single commit, of course. And it goes to how big is your feature, how big are you making as increments. So there are multiple answers and aspects to change in the way people are working. The ideal is to have shorter feedback cycles, so
Mm.
shorter iterations of everything, and everything will follow. And to the commit level, it goes like this. You can do something. Okay, let's go next to the Mikado method. Maybe some of you know the Mikado method, but it's really, really good. I don't use it all the time, but I use it when I really don't know the code. I don't exactly know what I need to do because I'm unfamiliar. So legacy code base is a good example. Or I tried and I'm stuck. I've been stuck for a while. So I'm like, okay, scratch that. I'm going to use the Mikado method. The Mikado method it's the brain dump, but with a concrete process. So if you like processes, welcome. Here is the recipe. The first thing you do is you write down what you want to achieve. So very much like the brain dump, like you write down on a piece of paper. It could be as simple as having a piece of paper and you write it down at the center. This is what I want to do. Upgrade the ORM, like implement that feature, fix that bug, whatever. Then you get a timer, and this time a proper timer, like something that will ring at the end and you will need to stop, like whatever. It could be your phone timer, but a timer that rings after, I suggest 10 minutes, and you will see why I don't make a bigger chunk. 10 minutes or maybe 15 minutes max, in my opinion. And then during that time frame, so it's very short and 10 minutes goes very quick, but you try to complete that goal within 10 minutes. Most of the time, it won't happen. Like if you start using the Mikado method, it's because you cannot do that within 10 minutes. Otherwise, you wouldn't feel the need to use it. What happens is 10 minutes goes by and your timer rings. You were not able to complete that thing. So what do? Second recipe. You couldn't complete your task, your goal. So what do? Well, you write down, you take a moment to write down what's blocking you. What do you need to do first? Turns out during this 10 minutes, I will realize that, oh, I need to extract this function first, and then I need to extract this one, and then maybe I need to do this first because it's in the way. So everything I discovered, I will write it down, and I will connect these to the main goal. These are sub goals, smaller steps. Then, and this is important, you need to revert the changes you eventually have made during that time box. And that's why I don't recommend you to make a bigger time box than 10 or 15 minutes max, because it's easy to revert 10 minutes worth of change. Like worst case scenario, it will take you 10 minutes to redo. It's not a big deal. If you have been working for an hour, it's very difficult to revert the changes. You don't want to do that. But reverting is important because you want to restart from a fresh state and do it again. Then you pick a sub goal, like extract the dumb function, and you put the 10-minute timer again, and you do it again. So you repeat the process. Eventually, after doing that, at some point, you will be able to complete something within 10 minutes. So maybe in 30 seconds or maybe in 5 minutes, you will do your thing. What happens then? First of all, you get a little dopamine shot. It's like when you see a test go green, you it's addictive, to be honest. So you're like, yeah, it's done. It's a good moment to do a commit. So if you want to do more frequent commits, this is also good techniques, because what will be in your commit is worth less than 10 minutes of work. So it usually will be a small commit. And you cross it off, and then you pick the next sub goal or goal, and you start over. And this is the full recipe. So at the end of the day, it's really like speed running. If you know that practice of doing all gains and trying to complete that in minimal amount of time. From the outside, it looks like that because when you open the PR, you have all of the commits in the correct order to solve the problem. And the trick is exactly like speed running. You died a lot of times, but every time you die, you go back a little bit backward in time and you try it again, like 10 minutes before, like Prince of Persia style, and you try a different path until at the end you have completed everything. It really feels like that. So here is an example of what the graph will look like. For you to get a sense, there are two phases when you're doing the Mikado method. There are two big phases. The first one is the expansion. Like you try to do things and you keep failing. Like the timer keeps ringing and you cannot complete this thing. So you keep adding more and more and more stuff to your graph, and it grows. It's not time wasted. Yes, during this time you won't commit a lot and you won't produce a lot of code, but you have this artifact. This graph is the work you have done. You have discovered everything that you actually need to do to complete that task, with things that are at least 10 minutes of work so far. So it's decent. Like refactor that function. Turns out it's a big deal, right? There are many things that needs to be done, and that's also valuable when you're at stand-up and you try to explain why you're still working on something. Well, here is the whole picture now. Eventually, you will start crossing off things. Like there will be a second phase, which is like you have figured out mostly everything, and now it's the productive part where you have the game plan and you're just delivering it. You're like, okay, I'm doing this, and now I can do that, and now that I've done all of this refactorings, I can do that next thing, and now it's easy to do. I can do that within 10 minutes. You do that, you do that, you do that. The nice part of this is you can also open maybe an intermediate pull request with at least these changes. I found that if you have this like graph, it could help the others understand what you're doing. And at some point you will end up here. Here it means that, okay, within 10 minutes, I should be done with the feature. Like this is the end. I'm arriving at the end, and I will just cross over the few remaining pieces of the feature. There is a book called the Mikado Method, and I would recommend you not to buy it now. Why? Because if you're like me, you're like, oh, there is a book. I need to buy the book and read the book, and I have 10 other books I need to read, so I'm gonna put that in the backlog of books to read. And you will never use the Mikado Method until eventually someday you finally go and read the book. Here you have everything you need to get started. So I would recommend you to try it once, twice, thrice, and you will probably have questions because, of course, in practice, you will find yourself in some situations and you will have questions. And when you have these questions, now is the moment when you buy the book and you find your answers to your questions. And it will be a more efficient way of using the book than just procrastinating until you use the method. I put you a link to a tool that I use. If you want to make it can fit on a piece of paper. Usually they grow, but I like to use a mind map tool. Any mind map tool usually does the job to quickly capture the IDs in a graph way, in a tree way, because it's really a tree of dependencies. It's your to-dos dependencies kind of that you're building. Any question about this?
That was just a question about the tool you were using for the Mikado graph, but you just answered it, so perfect.
Yeah, and you have the link. I use mind map because I like one thing I will look for is it's easy to create new nodes, but most mind mapping tool are good with this. The second thing I'm looking is, can I make it clear when it's checked, when it's done? Mind map, yes, I can put a checkbox icon like this. So I would recommend this, but any mind map tool works best in my opinion. And I'm not
This,
aware of
yeah, so sorry, this techniques reminds me the test commit revert techniques somehow.
There is, because of the revert part. Oh,
Yes.
the revert part is the part that feels painful for the. Well, it's not just developers; it's human. We don't like losing stuff. It's the loss aversion thing. We really don't like losing stuff, and so as developer, we don't like to revert code. And that's why you make it simpler, but you should train yourself. Like, for example, recently I spent some time developing a cool function, nicely tested to do one thing. And now we realize, okay, now we are using the feature. We realize this part, my cool function, we actually don't want to do that. We want to do something else. I will throw away that code. Like it, yes, it feels painful a bit because I spend 30 minutes, 40 minutes writing that cool algorithm I'm proud of, but turns out it's not a good idea. You should train yourself to let go. Like,
Yes.
and I won't just keep that function in case one day we need the same feature. No, I will kill that function because it's not used. And if you want to use it again, you can find it in your Git log. You use git log dash big G, the name of the function or whatever keyword you want, and it will spit out the commit where you created or modified or deleted the thing you're looking for. It's easy to find stuff in Git. Um, I will drop the comment in the chat because most people don't know, but you do git log G, the thing you are looking for. And if you try that, you will see that it's actually good enough so you can delete code and instead of commenting it.
There is also, thank you for your answer, Nicolas. There is also an interesting question from Rose who asks, do you keep track of your mind maps? Did it already happen that you came back to your previous mind map after a certain time or not?
Uh, yeah, interesting question. I don't think I ever really like sometimes I do go back to old pull requests because like it's 1 year later and I don't exactly remember why we did something. And so I use pull requests and I put a lot of information in the PR description. And usually I would put the mind map here, but the mind map was really to help me do the work. Once the work is done, it's not never personally I never used it again. I would probably redo no yeah but maybe
Okay.
I'm not
Depends.
saying you will never use it again. It's just
Mm,
that it's really when you're doing the thing it helps you work.
mm.
Once you're done, uh it's interesting as like forensics to understand how things were made, but you don't usually it's not the thing you really care about.
Okay, great. Thank you.
You're welcome. All right, let's move on to the next one. Hotspot analysis. This may be for a different target audience, but it's also interesting for developers. It's really interesting if you are in a leading position like tech lead or a consultant or a VP engineering, like something like this, when you need to prioritize how your team will solve technical debt. Uh, but even if you're a developer, you can use that and you can bring it up, and you will realize most people are not aware of this. So I'm sharing it with you. The key of it is when everything is urgent, nothing is. You probably know that. Well, everything say, "Oh, this is super important. This is super important." Yeah, everything is super important. So what do we start with? And in personal productivity and project management in general, when you need to prioritize stuff, you have different techniques. One that I really like and use is the Eisenhower matrix, because it's simple and it already most of the time it's good enough to clarify among the dozen things you need to do which one you do first. If you're not familiar with Eisenhower matrix, basically there are two axes. The first one is the urgency, like when do you need to do that thing for? Is it for tomorrow, the end of the week? Maybe it was due a week ago, or end of the year. Like, give a scale of when do you need to do that thing for. The other axis is the importance. Importance is okay, if you don't do it, how bad will that be? Uh, you will lose a big client, it's terrible. Other teams depend on it, so you have a big impact. Or maybe, well, it's nice to have, but realistically, if we don't do it, that's okay. Or we could do it later. Like no one, we won't lose a ton of money. Maybe we'll lose an opportunity, but there will be others. So you can usually assess relatively the task. You can tell this one is more important than this one in terms of impact. You put them in this little chart, and you prioritize the urgent important stuff. This is the things you need to work on. These things have the most value. The rest is distraction. Even if there are big things and they will take a lot of time, they are urgent, they are important, you need to spend your time on these. For the non-urgent stuff, well, with time they will become urgent eventually, so do them later once you're done, or they will become do it now. For the non-important stuff, if you can, I would say delegate it. If you're manager or whatever, for developers, I would say automate it. Maybe like find ways to, so you don't, like, it takes less time to do, or you're not the one doing it, because it's less valuable of your time. And eventually, if it's not urgent and not really important, well, drop it. Like, we again are afraid of cutting stuff. As a consultant, I work also on the project management part sometimes, where we look at the backlog, and I really like. I did that multiple times. It's maybe difficult culturally and in your position, but closing all of the backlog tickets and wait and see which ones will be reopened is always an interesting exercise, because it always takes a lot of time to juggle and prioritize 100 different issues. When you have only 10, it's very easy to decide. Uh, so important stuff will reopen themselves. When you're not sure, close it, and trust the world to remind you about this when it becomes important again. Anyway, what does that mean for code bases, for code? When people analyze their code base, usually they go for a static analysis tool. So a tool that will tell you, usually like with a code complexity, the code smells you have in your code base. So which part of the code base should really be refactored? And there are tools online for this. Some tools will even tell you how long they think that will take your team. And the problem with this is on the legacy code base, in my experience, it always spits out a ton amount of issues. And what do you do? Because when you have like 10,000 issues and it tells you it will take you 8 years to solve that tech debt, where do you start? Because, okay, but I need results within a few weeks, if possible. It would be great. So what people usually do is they filter out the small ones, the medium ones, and they only pick the critical ones. But even then, there may be still a lot of critical issues. That's probably an exaggeration, 2,000 critical issues, but it's not an exaggeration to speak about 100 critical issues. And I think, well, there is an axis that is missing here to effectively prioritize it, and it's the urgency. Now you know how bad the code is, but which code is the most urgent to fix first? And it turns out this is something you have. You are certainly using Git, I bet, and Git knows that information. So back to the previous question, that's why squashing too much is like destructive Git operation on version control make this kind of techniques a bit less efficient. If it's squash PR on you, it will still work on legacy code bases, but detailed Git history is actually very interesting and useful because you can do code forensics. Here, what we need to know is which files are touched the most. And you can ask this question for the past, like, okay, over the past year, yeah, it's a million-line legacy code base, but the team is only 5 people. Which parts of the code base have they worked on the most? And here's a command you can copy paste. Again, you will have access to the slide. You can copy paste this command, and on any Git project, it will give you this answer. So Git log is where all the information lives. You get the file name only of the past 12 months. It's usually enough. You don't need much more. Like last 12 months is usually good enough to give you an indication. You remove the fancy formatting. You just want the file names. Eventually, you filter out here the blank space. You can filter out the markdown, the JSON file, the YAML file, everything that is not really relevant in your output. You egrep, so you exclude these patterns. Then you sort these results to get the same file names next to each other. So then you can count them. How many times do I have this file appear in this history? And then you sort again, this time using the number that you get from the unique count. So you get the top first, and it goes to the less frequently changed file. And you pick the first 50. It's also good enough. The first 50 files give you a good indication. That will give you 50 files and a number, which is the score, which is the number of times it has been touched in the past year. You put that in any Google Sheet or whatever you want, and you combine this information with per file, what is the code complexity score of the tool you use? Like combine that with whatever you want, and you draw a graph. And at the end, you will have something like that. You will have the maintainability, like code complexity, and the churn, how many times this file has been touched. And you can put a dot for each of these files. And there you have your 4 quadrants. So this is something I did on the Docker Engine code base. So it was 2 years ago, but you could still do that analysis. And if you look at the code quality, you will see that there is a file here that is on the, oh, you don't see my, okay, mouse, but on the top left, there is a red dot at the very top of the graph on the left. This file is terrible in terms of quality. Like there are a lot of problems in this file, but it's barely touched. So it's not really a problem. You do not have to refactor everything for the sake of it. It's not helpful. It's not productive. However, there is a file that is a bit better. It's almost average in terms of maintainability, but it's touched all the time by everyone. This file, if you focus your refactoring efforts, will pay off the most. It will be the best return on time invested. And what I just said, return on time invested, is the kind of language you need to use when you're talking to product manager, stakeholders, non-technical stakeholders, to sell the idea of we need to do refactorings, we need to pay off technical debt. You will have a payoff on that time invested, because if we make that file super maintainable, well, our daily life will be easier.
Because it's always difficult sometimes to explain why we are going to improve the code and what will be the return on time invested. So it's a really good advice to talk like this to non-technical people.
Yeah. Don't use technical jargon. An analogy can help, but it's also like if you show these graphs, like it won't do everything because it won't say much more than your other arguments, but it will be a visual argument. Like they will see that you have done some analysis and you're not just an engineer complaining, oh, tech debt, the code is shit, we need to stop development. No, you're like, okay, but hey, look, I have a plan, and I'm saying we're cleaning up everything. I'm saying this is really annoying. Strategically, it's a problem. Let's fix this. And I found that managers are much more receptive to that kind of thing. Now we can talk. Now maybe we can have a plan because sounds like a trade-off. It sounds like you have a plan, and they like that. So, uh, like not just the hotspot analysis technique, but using it to discuss technical debt, I recommend. All right, let's move on to the approval testing technique. The gist of approval testing is what the system does is more important than what it should do. This is very true for legacy code because there are a lot of, well, all the time in my experience, people think the system is behaving a certain way, or there are specifications on how the system should behave. And in practice, you realize not exactly there are bugs, or there are, oh, in this scenario, it does this, and no one knew about this. Be very careful when you're in this situation because I've been in that situation and I fixed the bug. I wanted to, except people were using that. Like other systems were depending on the API I fixed. Released the fix, all good, I was happy. And then I got a backslash kind of because turns out other systems were depending on that bug or behavior, call it what as you want. But I did a breaking change when I changed the public confirm API or behavior. Sometimes it's really a bug that is known and annoying. Like when it's really a bug for everyone, you know it, the team knows it, it's flagged as a bug. When it's something you discover when like testing the code, be careful. It's more likely people don't realize or are depending on that behavior and they didn't know it was supposed to be a bug or whatever. So I'm just saying you can fix bugs, but when you just discover a bug while you're refactoring whatever, don't just fix it. Communicate with the team, with the rest, because maybe you need to preserve that bugs for the moment and come up with a plan. Anyway, back to your situation. You have a short deadline and you do not have tests. You need to change that code. How do you do so without breaking stuff? It's very difficult. The seductive idea of automated test, it will be much faster to know if you break something, right? Because if you do try to test it manually, you will have to test it manually every single time you make a change. And at the end of the day, that can take a lot of time. Plus, you can make errors. The idea of automated test is you're automating that work. You are making the computer verify it much faster than you can do, so you can go faster. Of course, the question is how fast can you write the test? Because if you take super long to write the test, then well, yes, with a short deadline, you won't make it. So it's always a balance. And approval testing is here to speed up writing tests on untested code. So it's a technique you use as a test after the code exists. It's a behavior that it has behavior. We want to preserve it, but we need to refactor the code because I need to change it. And the way the code is written, it's like I don't understand it and it's not easy to change. So I need to refactor, but refactoring is risky. So I want to put quickly a safety net on, okay, the code behaves like that. I want it to still behave like that. Can you help? Approval tests are here for that. So the idea is you generate something you can put in a string in a file, something you can store in a file that will be your snapshots. You're running whatever you're testing with some parameters and context, like what in an environment under certain conditions, and then you capture a behavior and you put that in a file. The idea is the first time it happens, you just capture whatever it does. The next time you run it, it will compare what it does with what it was supposed to do. And the approval part is if this is different, the test will tell you, well, this behavior has changed. Can you review and tell whether or not this is a valid change and approve if it is or not? Of course, there are a lot of edge cases. This will be worth a whole talk. I do not have time to do a whole talk on approval testing, but I will give you a link with much more resources because if you have side effects, if you have a database, if you have there are many different situations where you need to apply different techniques. If you have dates or data that you want to that are flaky because every time you run it, the information will be different. There are techniques for this. I will send you a link to answer all of these questions. But the idea is you capture the behavior, you use the test coverage. It's actually really good to use the test coverage here because it tells you what part of the code you're not testing yet. 100% test coverage doesn't tell you if the tests are good, but test coverage tells you which part for sure you're not testing. And this is a guide to say, oh, I need to add more parameters to get into this path until you cover everything. And once you cover everything, what I like to do when I want to be super confident, it's testing my thing. I try to put mistakes in the code, like deliberate one. I comment a line of code or I change a value, and I run the test just to see if they're passing or failing. And they should fail. And if they fail, now I feel confident. Okay, now I can play with that code. I have something that will tell me super quickly if something broke in this mess when I refactor it. At the end, it looks like this. So like this is a cross combination of all these parameters, and it will generate 24 tests, but you may have approval tests that will be like property-based testing, where you will be testing 100 combinations. It's like throwing buckets of paint to the wall to get it paint. It's not masterclass and everything, but it's super fast to get most of it covered, which is your goal. Your goal is speed, very quickly get most of the behavior under test so you can start working on it. The goal is you have an environment where you can do refactorings, and if you do a mistake, it will let you know faster than your colleague who does bugs and regressions because they're not using the test because they're trying to do it manually. Here's the link you will use to get much more information about this. I would recommend one thing: remove approval tests once you're done, if you don't need them. There are some scenarios where you would keep them for a long time, but usually you would like to remove them, especially if like if the test fails and you just don't read the report and update them, it's a problem. You need to remove these tests.
Quick question, Nicolas, from Florian. Is this related to the Golden Master? I think
Excellent
so,
question.
yeah.
Yes, Golden Master. I think it's the oldest name for this technique. It's very it's the spirit is the same. Other name, characterization test from Michael Feathers. It's the same idea. I'm using approval testing because these are the keywords that will give you the more resources if you type them on Google. There are libraries in different languages, and they are called approval testing. So look for approval testing. But yes, characterization test, Golden Master. I've seen also regression test, locking test. There are many. You probably are doing that also manually when you write tests on the code. You put something silly as an expect. You see the actual failure. You copy paste. You're just doing approval testing manually. But this is the approval test. They give you scrubbers and stuff, so you can remove the stuff that are flaky, for instance. But yeah, the spirit is this.
Great, thank you.
Any other question, or we're gonna conclude with the last technique?
I think we're good, yeah.
All right, let's wrap up with this one. So this technique, actually, it's not really a technique itself. It's more about a practice in general. This is a pixelized picture of artists performing on stage. Nice show. And this raises the question, when do we practice? Because these artists, they have been practicing a lot without an audience to make this look easy, right? And now they're performing. When we do work on our legacy code base at work, like with a deadline and features, etc., we're performing. we do not have time to try fancy new techniques because we need to release by Friday. So yeah, if you're not familiar with TDD, starting on your code when you have a short deadline is probably gonna generate more frustration than anything because you do not have the time to practice. And the playground. Here is a list of 5 playgrounds, coding exercises that are designed for testing, refactoring, dealing with existing code. So basically, in all of these, you have existing code that works, that is not ready, more or less realistic, and your goal is to, at the test, refactor the code, eventually change the code and evolve it. The good thing with these is the goal is not to solve the exercise, it's to try things. There are playground, sandboxes. You try one thing and then you revert everything. You start from scratch again. And this is something to practice. So I encourage you to use them. If you've never done such a kata before, you should start with the Gilded Rose because it's the most popular and most documented one that exists. And then I give you a list of an increasing order of difficulty because it goes closer and closer to real life examples. When do you practice? If you're lucky, like when I was younger, I used to do that in the evening because I had time. No, I'm a dad, so I do not have time in the evening and in the weekends to practice anymore. But that's fine because like when I used to be an employee, my company has training budget every year, and I could use that to learn interesting stuff like soft skills, very good. Uh, Frameworks, like libraries, frameworks, etc. It depends. But I used it sometimes to hire a consultant, for instance, and do a workshop for 1 week on dealing with legacy code. And we did Kata, for example. So that's one way. One thing you could do also, uh, take 1 hour every 2 weeks, for instance, with your colleagues that are interested to do that. Like you gather together in a room for 1 hour and you practice on an exercise and you try things and then you discuss how it went. Um, an hour every sprint. Usually, it's totally fine to do this in most company. Otherwise, you say it's a meeting. I mean, that honestly, that would be a productive meeting, which is not always the case. And finally, there is something called a code retreat, which happens on site or online. You can look for code retreats online and you will see. And there is one day in November, there is a global day of code retreats. So worldwide, you will have code retreats organized on Friday and Saturday. And you can use that it's like going to a conference. The whole day you will be doing coding exercises like this. And it's really good to try some of the techniques I presented. And just exchange with others and get out with ideas on how to deal with legacy code better. So these are my seven tips that you could use, and I'm just gonna conclude with the bonus stage, which is me plugging something I did in the spirit of this. I wrote an ebook basically to gather 14 techniques. Some of the ones I mentioned, like the Mikado Method, is here. The Hotspot Analysis is here, but there are other more. Some of them are more concrete refactorings, and they are the ones I use most of the time because yeah, they are valid in most of the case. For example, getting existing code under test, like there are steps that I cannot always try to take, so I documented them. You can have a free chapter if you go on the first link above and get a sense of it. And to thank you for having me today and spending all of this time. Use this link to get a 30% discount. And thank you very much. And if you have questions, we can take a few minutes before we wrap up.
Sure.
Nice.
Thank you a lot, Nicolas. It was very clear, very great content. I'm very happy we had this webinar today with you. I hope you guys in the audience found also the content interesting. If you are, yeah, if you have few more questions, feel free. Do you have maybe more links to share or another news, or is it good from your side?
No, it's good. Well, if you are struggling with legacy code, I put the link to my blog. Dive in, like there are 60 kind of articles. I like to dive to into different, much more content and stuff. And yeah, no, you can always, like, if you want to reach out to me, LinkedIn or Twitter, you will find me. And my DMs are open on Twitter, so I have people sometimes sending me questions. Totally fine. You can reach out to me anytime. I do reply within like a timely manner. And I know it's a difficult topic, but if you're here already, it means that you are interested into that topic. There is a community. Oh yeah, I forgot to mention this, but uh, if really legacy code is your thing and you want to hang out with other people who are, there is a community called Legacy Code Rocks. I'm gonna drop the
Ooh.
link in the chat. Legacy Code Rocks. They have podcast, which is interesting, but they also have a Slack. I'm in this Slack, and we do virtual meetups every week. Uh, Feel free to drop by. There will be much more people like me who have been working with Legacy Code for a while, and this is where I get a lot of ideas. So
It's a cool initiative. Great. Thanks for sharing this link. And congratulations for this book. Maybe I will try to spend some time reading the book. I'm also a dad for 4 months now, so it's more difficult
oh
for me. I was used to
yeah.
read before going to sleep, but it's more difficult for me. I have to reorganize my planning. But great job you did. Congratulations for this work. Um, yeah, thank you. I bought the book already, Tian. Okay,
Oh,
we hope.
I hope you liked it.
If you are here today, I think you liked it. Well, okay, thank you. I just quick. Can I just take the screen?
Oh yeah, yeah, go ahead.
Just 2 minutes. I'll just be quick.
Uh,
Don't worry,
Still,
guys.
go for it.
Yep. Just wanted to. I have this event. If you're okay, just to talk about. You are online in 10 days or something. 12 days. Okay.
Ah,
Uh,
yes, true. Yeah, it's online. Thank you. I forgot to mention it, but I don't want to overflow people with. Yes, I will talk about. So, if you're a JavaScript, TypeScript developer, this talk will be interesting to you. I will talk about types at the edge of the system. So, in short, you're doing TypeScript code, and yet you have a type error in production, and it happens to, like, if you're not aware of this, probably it's happening to you and you're not aware of it. So we're going to talk about that. I'm going to talk about Zod and how to use it to fix all of these blind spots.
Great. And of course, you will receive all the link, but here is your blog as well. One last thing I wanted to share. Our next webinar. We have some in French, but also in English. Our next one in English will be next month. We will talk also about legacy code with Khaled Souf. I
I
think
can
you.
vouch. I can vouch for Khaled. Khaled
Yes.
is like I work with Khaled, and he is so I have my specialties. He's really good with DDD, domain driven design, and we collaborated on that. I did that talk. We collaborated on that talk, so it's going to be very interesting. If you are interested in domain driven design and you wonder how do you apply that to your existing code base, go to this talk. It will give you answers.
Thank you, Rad, for promoting my event. uh, so yeah, okay, great. And I think it was the last thing I wanted to show. And of course, if you're interested in a great way to share your coding standard, just take a look on promyze.com. I think we go on the timing. So I don't know if we have other question or not. Sorry, I'm just gonna stop sharing my screen. The DDD talk will be interesting. It is. If Nicolas says it is, you can trust
No, it
Nicolas.
is.
Well, so I would like to thank you again, Nicolas. We really spent a nice hour with you, and I know you are in the middle of your day, so we I would like to wish you a great second part of your day, and hello, you guys. We'd like to thank you for being here today, and I hope we see you soon for our next webinar. And yeah, I think we're good.
We're good. Thank you very much. Merci, Cédric. Bye bye.
Merci. See you very soon. Bye bye. Thank you, Nicolas.
Thank you.